Hello everyone, my name is Hari Krishna Yadav and my presentation is on additive manufacturing and presentation topic is introduction to additive manufacturing process. So content which I am going to discuss is definition, materials and how additive manufacturing process works, difference between additive and subtractive manufacturing, types of additive manufacturing, advantage, disadvantage and applications. So first coming on the definitions. So additive manufacturing is layer by layer addition of the material. We will deposit material in the form of the layer. Then after we will add these layers by using binder or heating element like laser or electron beam. So by additive manufacturing process we can make lighter or stronger part and system. So material we can make material we can use for additive manufacturing products are polymers, metals and ceramics. How additive manufacturing process works? First, it works on the reverse engineering process. If we have any product, then we will put in a 3D printer, 3D scanner, and it will scan it and convert it into a 3D drawing. Or we can directly make the 3D drawing by using AutoCAD, SolidWorks and Creo softwares. And if our drawing contains any moving part or any mechanism, then we will check it into the modeling or simulation testing. Then we will do this, and if everything works well, then we will move forward. We will put our drawing into the slicer software, and slicer software will divide our 3D drawing into the into the layers, and it will create .str file, and .str file will contains all the instruction which our hardware will read, and hardware of additive manufacturing process will read, and product will be built in the 3D printer, and then post processing will be done and testing will be done. So this was the process, and the difference between additive and subtractive manufacturing process is additive manufacturing is layer by layer addition process. Material will be added layer by layer, and subtractive manufacturing is layer by layer removal process, material removal process. Additive manufacturing process usually works on the low melting point materials like plastic, and subtractive manufacturing process is applied to the all solid materials, and density can be controlled in additive manufacturing process, but in subtractive manufacturing process we can't control the density. No material wastage in the additive manufacturing process, but in subtractive manufacturing process burst chips and deposited ions and dissolved ion and vapors are formed. So that is why there are material wastages. Complex shapes and fully enclosed internal hollow parts can also be formed by additive manufacturing process, but in subtractive manufacturing there are limited capability to form complex shapes. Uh, Even we can form fully enclosed hollow part, but if we use joining process to join two hollow parts together, then the fully enclosed hollow part will be formed. And additive manufacturing works on the narrow range of the materials, but subtractive manufacturing works on the wide variety of the materials. Additive manufacturing process is time consuming and costly. So, but superior quality of product and of desired property can be gained. Subtractive manufacturing is time efficient and economical process. That is why it can be used for the mass production process where we don't need such a high quality products. So types of additive manufacturing process. Type of additive manufacturing process depends on how we are adding this both layers. Like if you are using binder or if you are using any heating source. So, and one more mechanism I want to talk, that is powder deposition mechanism. There is a powder stock which whose platform goes up for deposition of every layer. When it goes up, then the roller will drag the powder onto the build platform. So material will be deposited, powder material will be deposited on the build platform, and build platform will move down for making the space for the another deposited layer. So again build platform, again powder platform will go up, and we will use roller to deposit the material on the build platform. So that was the mechanism to deposit the powder, and now we are talking about the we are coming on the first category, binder jetting, in which we are having a thick binders adhesive material which will be used to bind the layer together. For after the deposition of the powder, we will use binder where it is necessary, to where it is required. So then again we will deposit another layer. So where the liquid binder is present, those layers will be joined together. Those powders will be joined together, and where the liquid binder is not there, those powders will remain as it is. And directed energy deposition process, here we will deposit the material, and electron or laser beam will be deposit on that, and then it will be converted into melted form and or the liquid form, and layer by layer deposition of the material will take melted material will take place. So there will be this both layer will all layers will fuse together because they are already in the melted form, and this process will be repeated until the product is formed. Material extrusion process, there is a material spool and which is unbinding, and wire is coming out through the nozzle, and there is an arrangement in the nozzle. There is an arrangement of heating arrangement. There is an heating arrangement, and if the wire is passing through the heater, it is converted into melted form, and we will move the laser from left to right so that we can deposit another layer. And layer this by moving nozzle from left to right, we will deposit we will keep on depositing layers by layer. So this layer will be fused together because material is already in the liquid form. Powder bed fusion, here the powder will be deposited according to the previous process, which already have told that powder deposition mechanism. And in space of that using binder, we will use laser to cure the layers, and where the laser will be concentrated, and there the material will be fused, powder will be fused, and they will stick together. And sheet lamination process is just like a sheet welding process. There we will deposit the material in the form of sheet, and then again we will move we will do ultrasonic welding, or if we are depositing sheet instead of paper, then we will use binder to join the sheets together, and then we will use laser for cutting the required shapes, and this process will go on until the product is formed. Then wet polymerization process, in which we are using a tub which is full of the photopolymer resin, and there is a build platform which is going down for deposition of another layer for new layer. When it goes down, resin climbs up and deposited on the surface. So and then after we will cure that layer with by using laser or electron beam. So again this build platform will go down, and again this resin will climb up, and the new layer will be deposited, and we will cure it by the laser. This process will go on until the product is formed. So again material jetting process, in which in the process we will use the different type of material like build material and support material, and this both materials will be jetted or jetted on the build platform in the form of the jet, in the form of layers. So two mechanisms we can use to deposit this material, like continuous jetting or demand and drop process. So after layer have been deposited, we will use UV curing lamp to cure the layer, and then after we will deposit another layer, and this layer by layer process will go on until the product is formed. So advantage of the additive manufacturing process. Additive manufacturing process is promoting the decentralized manufacturing, because we don't need if additive manufacturing process is there, then we don't need really a big organization, big working station of producing so many products at the same places, and then after transporting setting up whole transportation system to transport things. But in this, if every consumer is having 3D printer, then every consumer becomes a manufacturer, and working stations will also be improved, will also be increased, and so industrial efficiency will also increase. Material wastage is also can be reduced, and it is easy to make customized product. As already we know the material wastage, there is no any chips burst and uh, deposited iron and vapors. So that is why there is less material wastages, and it is easy to make the customized product, because every person need a different customized product for themselves. They everyone needed different size of material, so everyone can print that whatever they want. Prototyping cost is less. Prototyping, and even when we are producing a single specimen, single product, then also it is economical and fast processing, because for when we are doing a mass production, then what we need a mold. We need to make a mold, and then after we produce it. When we are doing a small production, then m- making cost of the mold is really high. So for a small run, this process becomes economical and faster. No need of in-hand inventory. Suppose if someone is having someone is producing an equipment, then they need to produce inventory also, like spare parts. So whenever the demand comes in the market, they need to supply that. But in if someone is applying additive manufacturing process, then they don't need to produce the don't need to have the in-hand inventory. They just need to have virtual inventory, and whenever the demand is coming, they can produce it and supply it. So by additive manufacturing process, recreate and optimize the old legacy parts. If someone is having old model car or old model equipment, then it is really difficult to uh, get the part spare part in the market. So that is so they can print that part into the 3D printer, and then after they can replace it. So that's how they can restore their old legacy. And any every equipment's lifetime depends on the spare parts. So people will not have to dependent on the market, what market supply of spare parts. They can just print the spare part, and they can improve the equipment life. We can improve the part reliability also. So we can by making better design, and by uh, using better material. So we can consolidate assembly into the single part. Here I want to go into the previous place, where here we use only two material, because we needed two material. Suppose if we want to make an assembly which contains 4 and 5 parts, and every part have been made with the different materials. So here we will use 5 or 6 materials, and parts of material. Then after we will jet it in the form of the layer, and the whole assembly will be formed layer by layer. So and this process is computer operated and fully automated. And as this process is developing, AI driven, it is developing towards AI driven. So disadvantage of additive manufacturing process is regulations. There was some ban on the printing of plastic handguns, because they were really difficult to scan and find if there is any plastic gun in the by metal detector. It was really not able to scan that and find. So that is why US government have imposed the ban on the 3D printing of handgun. So if any process is facing this type of regulations and restrictions, uh, it is really difficult for that process to grow. Size restrictions is also there. Product size depends on the printer size or build platform size, how big printer we are using. So big printers are also available in the market, but their cost is so high. And third, production cost is also high, because printer cost is high. And additional material, if you want to add some additional material, additional property, then we need to add some additional material while making the powder. So uh, after making the product, we can't add any additional material. So this is the disadvantage. We can't improve the property after making the product. Production time is also high, because we are depositing layer by making the product layer by layer, and thousands of layers have been deposited. So that is why production time is really high in this process. Post processing is also have been done. Post processing is also important, because sometimes finishing is not that up to that marks, and when we are using binder, then there can be impurity in the binder, and there can be some air voids and gaps also in even due to discontinuity of the nozzle jetting system. In aerospace and automotive industry, we can use for additive applications of additive manufacturing process. In aerospace and automotive industry, we can use for making product, for making prototype, and for reducing the weight of the automobile or aerospace, or or aeroplanes. So for making machinery, in machinery industry, we can make it for making component and for making prototyping. Prototyping is really important. Before making a real scale model, we need to make a small scale model, so that we can check it if that model can run in the real condition or not. In medical implant, it is also applicable. Skull implant, hip joints, body parts, robotic hands also can be made by the additive manufacturing process. And shoes, in the consumer goods like shoes, customized consumer goods like shoes, watches, hats, and other types of goods can be produced by additive manufacturing process. And architectural field, in architecture field, if there is a big building, large building, huge building, then what we can uh, make a 3D drawing, a 3D print of that at a low scale, 3D model of that building, by scaling, by making a 3D drawing of it and printing it. And in food industry, different type of chocolates, candy, and cakes can be formed by the 3D printers. So these references I have followed, and thank you for listening me.